As was mentioned in the module summary, economics is a soft science. That is, unlike the hard sciences, hard, cold facts cannot be derived from logic, experimentation, or data analysis. That's because with all social sciences, there are too many independent variables that affect any one dependent variable. Furthermore, these variables cannot be controlled as you'd control variables in a physics or chemistry lab. That's what laboratories are for, controlling variables. But for the economists and other social sciences, society is the laboratory. And people aren't going to act like you want them to just because somebody's doing an experiment. So, here's the problem. We don't have a complete list of what they are. Even if we could identify them, we don't know their weights. That is, we don't know the intensity of the impact that they would have on the dependent variable. And they can't be controlled, as you could say the temperature or humidity in a physics lab, and they're constantly changing. There are, however, a few laws that economists can count on. One example is the law of variable proportions. Technically speaking, it isn't an actual law as we've defined it here. It hasn't been proven mathematically, or it hasn't been proven that it happens in every case by replicating the outcome in an experiment. It's actually more of a principle. But it is such a reliable principle that we can cheat a little bit and call it a law. The law of variable proportions states that the relationship between additional units of input and the resulting units of output is, after some point, not linear, ceteris paribus. The concept of a linear relationship can easily be shown with a two-dimensional graph, with the independent variable input on the horizontal axis and the dependent variable output on the vertical axis. A linear relationship will produce a function that is a straight line. So the law of variable proportion says that it's not going to be a straight line. But the nonlinearity doesn't have to set in right away, just after some point. After some point, ceteris paribus. That means everything else has to stay the same. So the law of variable proportions shows up in two ways. The law of diminishing marginal returns and the law of increasing marginal costs. These two laws are the obverse of one another. That is, they are a different way of looking at the same thing, a different side of the same coin. Let's start with diminishing marginal returns. Now, the word marginal, you'll recall, means incremental. So, as more units of a particular input are added to the production process, after some point, the additional output resulting from the additional input will begin to diminish. Let's consider, for example, the case of the gravedigger. Let's suppose that one person can remove 1 unit of dirt in 1 period of time. Now, who knows what a unit of dirt is? It doesn't matter. Or a period of time, how long is that? Again, that doesn't matter. Okay, so now 2 people can remove a total of 2 units of dirt in 1 period of time. Notice, however, that when we add a third guy, total output goes up, but it only goes up by a half a unit, whereas when we added the second guy, it went up by a whole unit. Now we add a fourth guy to the grave. Now keep in mind that the size of the area in which they're digging on does not change. It remains constant, irrespective of the fact that there are more people working on it. And look what happens to the marginal or incremental output. When we add the fourth guy, there is 1/4 of a unit of output that is added as a result. Look what happens to marginal product. That is the incremental increase in output as we add more units of input. As you can see, after some point, in this case, after the second guy, marginal output begins to diminish. Total product is going up as we add more units of input, but after some point, marginal product is going down. That falling marginal product is where this law gets its name, the law of diminishing marginal returns. You often hear this phenomenon referred to as the law of diminishing returns. But as you can see, that's not quite accurate. Total returns, in fact, are going up. They might actually go down eventually if we were to pack, say, 10 guys into the gravesite. But this law describes what will eventually happen to marginal returns, not total returns. So let's now examine the obverse of the law of diminishing marginal returns, the law of increasing marginal costs. Suppose that the grave digging company had to pay each one of these guys $10 per period. So there's the $10 that we had to pay the guy, and as you can see then, that first unit of dirt cost $10. So we add the second guy, who can also produce a whole unit of output in that period of time, but we have to pay him $10 too. So you can see then that 2 units of output is going to cost us $20. The marginal cost of the second unit of output was $10. Now we add the third guy. If you'll recall, the addition of the third guy only resulted in an additional half unit of output. Now we have to pay the third guy 10 as well, so that half unit of output is going to cost us 10. Let us suppose that we just keep him on for a little while, let him finish his job, let him finish producing that whole unit of output, let him dig up that other half unit of dirt, and there's no further diminishment of his productivity. And so that means the first half cost us 10, the second half unit cost us 10, so that entire third unit of dirt is going to cost 20. So here comes the fourth guy. And if you'll recall, by adding the fourth guy, we only added a quarter of a unit of output to the total. Now, it would be wrong to say that the fourth guy only added a quarter of a unit. The fourth guy is just as productive as the others. It is the productivity of their collective efforts that is declining. The marginal output of the fourth guy was 1/4 of a unit of dirt removed from the grave in one period. But we have to pay him $10 a period, so that 1/4 unit costs the company $10. Now, if we keep him on to complete the removal of the whole unit of dirt, assuming no further diminishment in productivity, if the first quarter cost $10, the next 3 quarters will cost $10 apiece, making the total cost of that fourth increment of output $40. And that would bring the total cost of 4 units to $80. By looking at the schedule, you can see that as we produce more units of output, total cost is rising, and because the collective productivity of the group is diminishing due to the law of diminishing marginal returns, marginal costs are also rising. Those rising marginal costs is where this law gets its name. Let's investigate a little further this concept of the law of increasing marginal cost. In particular, let's look at the impact that the law of increasing marginal cost has on the production possibilities frontier. You are already familiar with the concept of a production possibilities frontier. That line is called a frontier because it shows the outer limits of a firm's or a country's productive capabilities. As you already know, a combination of good A and B, represented by a point inside the line, is feasible, but it suggests an inefficient use of the scarce resources. The various combinations of good A and good B that can be represented by a point anywhere on the line indicate the maximum possible production and can only be achieved if resources are used to their maximum degree of efficiency. A combination of the two goods represented by a point outside the line is not feasible. Simply not enough resources to achieve that combination. So now let's examine the impact that the law of increasing marginal cost has on the shape of the production possibilities frontier. As you can see here, the production possibilities curve is concave to the origin. That means it bows outward. If it collapsed inward, that would be known as convex to the origin. Let's now examine why the law of increasing marginal cost would cause the production possibilities frontier to be concave to the origin. On this graph, you can see that this firm or this country is producing 1 unit of good B. This requires the use of some of its finite resources, and therefore it cannot produce the maximum amount of good A. The difference between the maximum amount of good A that it would be able to produce and the amount of good A that it is actually producing is the cost of producing that first unit of good B. As you can see here, the sacrifice of good A is very small, and you have to look very closely. Now, let's let this firm produce a second unit of good B. The amount of good A that it can produce diminishes yet again. The amount by which it diminishes as a result of producing that second unit of good B is the marginal cost of that second unit. The difference between the amount of good A it can currently produce and the maximum amount that it can produce, that is, where the production possibilities curve intersects the vertical axis, is the total cost of producing the 2 units of good B. Notice that this graph is showing the total cost of producing 2 units of good B and the marginal cost of producing the second unit of good B. You can't see it very well here, but the sacrifice of good A was greater for the second unit than it was for the first. This will become more clear in just a second. Now, by showing the third unit of good B produced, it is clear that the sacrifice of good A was greater for the third unit of good B than for the second. This is the law of increasing marginal costs setting in. It is even more evident that the marginal cost of producing the fourth unit is greater than the marginal cost of producing the third. Increasing marginal cost is even more apparent here, and very apparent here. It should be intuitively obvious to you now that the law of increasing marginal cost causes the production possibilities frontier to be concave to the origin. As output increases, the marginal cost of additional units of output increases. This concludes this video on the law of variable proportions. We will discuss this concept again when we start talking about supply in Module 3 entitled Supply and Demand Analysis. You'll also learn another economic law in this module, the law of comparative advantage.